Kesseltronics BayTimer is used to indicate to customers how much longer they need to wait for their car at a quick lube location. The system comprises of a bay screen, a waiting room screen, a main controller, a secondary controller, and the ultrasonic sensors that are mounted in each bay. The main controller and secondary controller are connected to the bay screen and the waiting room screen using an HDMI cable and a USB cable for power. The main controller also has a 24-volt DC power supply that is used to power the ultrasonic sensors that are located in each bay. The ultrasonic sensors are mounted 11 feet from the floor in each quick lube bay. The sensors are mounted using half-inch EMT conduit that is dropped from the ceiling. The individual sensor mounting boxes can be press-fit over the EMT conduit. So this is the ultrasonic sensor that is used to pick up vehicles when they're parked in quick lube bays. It has two ultrasonic transmitters and receivers, so these elements need to send a signal down and bounce off the car, and then they can tell when it's there. So this needs to be installed 11 feet off the ground. Its address is set here with these dip switches. That would be number 1. It's a little bit counterintuitive that switch number 7 being on is number 1, but we will ship these out when they're received. They're labeled Bay 1, Bay 2, Bay 3, and they're pre-addressed. But if you're ever curious, that would be 1. Just 6 on is 2. 6 and 7 together would be Bay 3. These, the way they're mounted, is with EMT conduit that comes down from the ceiling and then has a 90-degree bend put into it. The junction box that's supplied with the sensor gets mounted to the EMT conduit. So if the EMT conduit's at a 90-degree angle, just press fit. And then the box is mounted facing down, and it's a snap-on connector, and I'll flip it over so it's easier to see, to hold the sensor in place. And that's it, aims down, measures the car. Now let's get to the electrical connection. So we use Cat5 cables to interconnect the sensors, and the way to do that is to run the Cat5 cable through each conduit and then crimp the ends on afterwards in the standard manner. For the sake of this demonstration, I'm going to run the cable through the conduit with the ends already crimped on. I don't suggest doing this in the installation as it greatly complicates things, the running of the cable. So what we would have here is cable coming from the previous bay and a cable going to the next bay or the main controller. So if we were to think of this as being bay number 2, then this would be coming from bay number 3, this would go to bay number 1. On the Cat5 cable, it's actually not carrying Ethernet, it carries a power signal and RS-485. And this board is supplied to simplify the connection so that we can terminate signal from bay 3, signal going to bay 2, and then the sensor can tie in right here. And this is all upside down, right? Because you would be doing this 11 feet up in the air. Sensor goes on, you can see there's the little keyed markers so that they can snap into position. And that's it, sensor's installed. So this would have actually been like this, where the separation between here and here would be 11 feet. That's it. So what we're looking at here is a sensor that's actively working, and you can see it's being read by the main controller every time the red light flashes. The green light being off indicates that it's an open spot and there's no car there. If I was to put my hand in the way, you can see the green light turning on because it's picking up an obstruction. So that's the way you can tell if the sensor's working or not. If you park a car underneath it, you should see that green light turn on. When the car leaves, there is a certain debounce time, and then the green light should turn off.